All right, so let's start. Hello, everybody. Welcome. Thank you for being here. Our topic today is going to be how to troubleshoot secure firewall Datapath issues, right? So I'm Eder Pacheco, but who is Eder Pacheco? Well, I'm a TAC escalation engineer from 2 years ago, and I've been in TAC for 4 years ago. I'm a Toastmaster member. I'm a huge Star Wars fan, so you can see it. I'm a Patriots fan, the best team ever in the world. I mean, 6 Super Bowls can say that, not me. I'm a sports lover, right? And for sure, I'm a security network passionate. So, our agenda today, what are we going to see? We have an overview. We have our secure firewall portfolio, the secure firewall architecture, navigating through the secure firewall prompts, troubleshooting examples, and then we have a conclusion. So, for the overview, what is this about? What are we going to see? So, in a normal, in a common way, we are going to check our network, our campus, or our data center, where all the network devices are connected, right? And normally, we go to internet, and that's it. But will be simple as this. But not always is like that simple, right? We have sometimes a secure firewall, and sometimes we think there is a problem, there is a total outage. Well, actually, it's different to have a total outage that not just have internet connection, right? So we're going to see that difference. So first, what are the first steps to identify a network impacting issue on a secure firewall? And then the best practice applicable to any secure firewall platform. So our secure firewall portfolio. We have the small 1K and 2K series. Then we have the 31K series. For our data center and campus, we have the 4K series, the 41 and the 42. And at last, we have the biggest box. Why this is important? Because they have a different way to handle the software that they run. For example, for the 93 and the 41 series, we have separate components. We call it the FXOS and the application that you are going to run, right? As the FTD or the ASA. For the other ones, we have the bundle component, so they troubleshoot it a little bit different. So we are going to see that later. That is why this is important. So, the secure firewall architecture. For this, we have our chassis, or our hardware, our common box, right? And we have our front interfaces that goes directly to the network, right? The physical interfaces. On our boxes, we have an internal switch that passes through the packets to on a backplane uplink to the security model. That security model can contain 2 softwares. We can have the FTD or the ASA, and depending on the software that you are running on the application, we are going to have 2 engines, or one of them. The first of them is the ASA, a basic firewall that we have the data plane, the Lina engine, that we can create ACLs up to layer 4. But if we have next generation firewall, the secure firewall, we can have both. The data plane that is going to be up to layer 4, or we can have the Snore engine, but this is just for FTD. So, if we have our chassis, we have different prompts where we can troubleshoot our problems, right? So, let's identify where we are. At the beginning, if we log to the chassis, to the box, with the IP address of the chassis, we have the FXOS CLI. In here, we have the operational system overall, the hardware. So we can check all the hardware issues. We can check all the hardware components that we have on this, right? If we go further, we can go the diagnostic CLI. We are using for troubleshooting, for some show commands, even for some configurations. Then we have the defense CLI that is used for management and some configuration and troubleshooting as well. Then we have the privilege exec mode. So we are going to check the show commands, and on Lina, we can just click enter when it asks for the password, but don't worry, because this is just for show commands. We cannot do any configuration actually on this. And at the last, we have the expert mode. This expert mode is used only for documented procedures and for tag uses only purposes. So if we go to here and we are going to put some commands or make some changes, be sure that all of these changes are well documented by Cisco and you can proceed them. All right? So if we want to see this like on an overview, like graphical, we can see something like this. We're going to have our secure firewall, our first prompt, and there is the platform mode and for the 2Ks and all the other platforms. And if we go further to the application, right, we are going to put connect module 1 telnet for the 41 and the 93 only. If we have the other devices, we're going to put connect and the name of the application. Could be, for example, connect FTD or connect ASA. After that, it's going to show us this kind of prompt for the 41 and the 93. If we have the other solutions, we are going directly to the application, right? And if we go further, we are going to put the same, connect FTD or connect ASA. And after that, we are going to get the FTD unified CLIs. We call it normal as glitch, right? If we need to go further than that, for example, to the expert shell that I showed you before, we are going to put that expert, and we are going to be on the expert mode. If we need to go to Lina engine, we apply system support diagnostic CLI, and after that, we are going to be on the Lina shell, okay? So, troubleshooting. What about if someone has an issue on his network? We have a problem, we cannot reach some servers, we cannot do anything. The first thing that TAC recommends is go to check the hardware, if the hardware is working good, right? So we're going to connect to our FXOS chassis, and we can, for example, at the beginning, put show fault on that prompt. It's going to show us every fault and every issue that the hardware, that the chassis has, right? And it's showing something like this. You can see something like this. And for example, we have a lot of descriptions here, but for example, I highlighted this. The Ethernet port 1/4, it's down. It has an operational state down. So we can check that and say, okay, maybe there is a problem with the connection, maybe there is a problem with the cable. Let's see if there is a problem there. And now, it's a hardware-related issue, right? But this is so basic. Let's check the module. Let's check the application, if it's running good, if everything is good there. How to do it? Well, on the same prompt, we're going to put a scope SSA and then show app instance. These commands help us to check the state of the security model, in this case, of the application that is running. In this case, we are running FTD. It's going to give us a lot of information about the security model, that is the application that is installed. In this case, what is the operational state? In this case, it's online. Could be disabled mode, or could be like it's in the starting mode. We can see all the process that is running on that moment. The running version, if it's on a native state or it's a container, if it's on a cluster mode or it's just native, right? So this is something that we can check. The blade chassis health check. We can check the blade if it's working good. So we can put scope chassis 1, then scope server 1/1, and after that, check the firewall security model, right? With show FSM status. So we're going to see something like this. If there is an error, as we are seeing, we are going to get the remote error code. We can extract that, right? And you can see that it's a description as well. So this is a really complex thing, right? It's waiting for BIOS post-completion information from IBMC. Okay, this is a lot of things. But something that we know is that we have an issue on the blade. Maybe we cannot go further than that. So maybe there is time to get TAC involved on this. But if you extract all of this information, will be a great thing to start troubleshooting, because the TAC, it can see this, it's going to see this, and can know where is your problem. If we need to troubleshoot, if we need the first steps, we can go further than that. But at the moment, the TAC engineer can check this and say, okay, we can go for this, from this path. To check the model, the app instance disk state, because as we know, all of this is hardware related, we can go show detail after a scope SSA and the slot. And we are going to see something like this. For example, we have this format state, and it shows format failure, right? So on the bottom of that, we have the error message that says the partition of the security model are not compatible. And we have a first troubleshooting step saying by the box, reboot the security model for possible recovery. So if the problem is really here, we can know what to do, at least at the first step. But before to do this, please take a troubleshooting file before, if we know the root cause of this issue, if we have to know what causes this problem. So we can check the engines as well. So if we go to Lina and put show CPU, it's going to show us the state of the CPU. If it's really charged of, I don't know, maybe with on the 90%, and there is a slow on the network, or there is a problem, could be related to Lina. So maybe we can know where to start to troubleshoot. In this case, it's 0%, it's okay. As well, we can check the memory with the show memory. As you can see, there is 82% of free memory, so I don't think the problem is here. What about the disk state? So we have, with the dir command, 93% free on the disk. So I don't think there is a problem. We can still write things on the disk, start sessions and things like that. So the problem is not on the disk and not on the Lina engine. Let's go to Snort. If we go to the Spurt shell, we can see the top command. Top command is going to display a lot of useful information. The process on the amount of percentage on every process, the process that overall the CPU, and that is something important to us. In this case, we have 33.4%. It's a really low amount of charge for the CPU on the Snort engine. So I think we are good here. We can go further than that. To check the memory state, free space -G, and we are going to extract the amount of the RAM free on gigabytes. We have 74 gigabytes of RAM free, so the problem is not on the memory, right? What about the disk state? We can do it as well with this command. And after that, we are going to have all the directories on the Snort engine. As you can see, there is a lot of space here that we can still working without any issue. But let's see. What happens if someone really cool, let's say someone like Eder, wants to watch the score of the Patriots game? We go on our computer, put the Patriots score on Google, and we check something like this. And we say, okay, there is a total outage. We don't have connection to nothing, to internet. Well, is that true? Let's check. Maybe we cannot reach internet, right? But maybe we have connection to our internal resources. For example, in this case, we are able to download some files, some things from an internal server, but we cannot reach internet. So there is not a total outage. We don't have connection to internet. That are two different things. So let's try to troubleshoot this. So the first thing that I will recommend is that we can reach our destinations or the connections that we have. For example, here, we can ping the internal server with the 10.10.10.3, and we are going to see that we have full connection, right? We have connectivity. This is the most common way to check that. But what about internet? If we try to go to any public IP, we have issues, right? Okay, so let's try to start to troubleshooting this. Let's check the Lina prom. Check the involved interfaces. This is really important, so we can know how those parties are connected to our firewall, and we know if we can reach it, right? So if we use the show IP on Lina prom, we're going to display the interfaces involved in this issue. We have our outside interface, and this practice use is going to be for the internet connection. For the inside is going to be where our PC host that we are using for this test is located. The DMC zone is where the internal server is located. And we can check the routes involved on this. For example, if we need to check how we are going to reach those from the firewall, we can put the show route command, then the IP that is for our interest, And then, for example, this is for our PC host, and it's going to display this information. Something that is important to us is how it's connected. It could be via maybe a routing protocol, or maybe from another host connected. In this case, is via inside. So we know that the PC host that we have on our internal network is connected via inside. We can do the same for the server, and we are going to display that it's connected via DMC interface. And for the internet connection, we know that we have to get to that with the default gateway, right? So there is not a network on the table, so it's going to take the default gateway to reach that. So let's use some captures. The capture syntaxes, how we are going to put those captures to check this, this connection. So we can put the capture command, the name of the capture, the interface that we are going to use, in this case the interface inside, the trace match to trace all the packets, the protocol that we are going to use, in this case is going to be ICMP, it could be TCP or UDP or the protocol you're using, the word host, the IP of the host that is involved in this, another host again, and then the IP of the server, for example. So if we put show capture capin, that is the name of our capture, we're going to see that we have this connectivity, right? So we have the request and the reply. So there is a good connection there. If we do the same, but on the other interface, where the egress interface is, the DMC zone, we have the same packets because we have bidirectional communication, so everything is good there. But let's check about the inside going to internet, right? So when we try to do that, we see that we have this echo request, but there is no reply, right? So maybe there is some problem there. Let's check directly on the capture what is happening. So if we put show capture, the name of the capture, trace, we are going to check the packet number 1 that arrives to the firewall, and with the command detail, it's going to give us all the information that we need. We are going to see something like this. A lot of phases, right? A lot of phases. They are really important for troubleshooting, but at the moment, we are going to focus on the thing that is interested for us. So at the phase 1, we are capturing the packet, right? And we are allowing it. Then on the phase 2, we have an access list that allows that packet. That is important. You are seeing, if we see a drop, it's because we don't have an access list. In this case, we have it. And then we, after a lot of phases, we have the result. And you can see no route to the host and a drop it. So, but we know for sure that we have a default gateway. Let's check the default gateway. So if we go to the FMC and go to this path, we're going to see something like this. And as you can see here, we have actually our default route for any IPv4 to our outside interface, that is the facing to internet, and we have a gateway. This is the IP of the gateway. So maybe something is wrong with the FTD, with our chassis. Let's check. If we go to this path, we are going to see something like this. And as you can see, we have a problem on the interface, right here. So let's go to the chassis and see what is happening, because the chassis is going to show us all the hardware issues. On the chassis here, you are going to go to this path, and you are going to see something like this. And as you can see here, we have our interface disconnected. It's not turned on. Maybe a Patriot hater turned it off so I cannot watch the game, right? So let's go further in that. Let's turn it on that. Okay, now we are on green state on the FXOS chassis, and now we are on the green state on the FMC. So I think we are going to be able to check it the game. Let's use the same commands. So again, the test, you know how to do it. With the detail command, it's going to show us something like this. And the phase 2 is being allowed, so we are good. Now we can see the both interfaces are turned on, and the action is allowed, right? So let's, again, try to do the same. So we can download things from our internal server, but again, we cannot go to internet. Okay, let's use some useful tools to check what is this issue. So let's use capture traces. So we're going to put the syntax, the same syntax, but at the end, instead of put the IP address, we're going to put any. Why? Because we are going to internet. We don't know what is the IP address that we are going to reach. So if we put any, we are going to put the show capture, the resort capture, all the information that we put on that capture. We are capturing bytes. You can see it there. And now, if we put the show capture capin, we have DNS requests. So we are trying to go to internet, right? So now we know that after trying to go to check the Patriots game, we try to do a DNS request. So actually, we can see on the detail those captures, it's being allowed. As you can see here, we have a rule that is allowing these DNS connections, and the interface is up. But for some reason, we cannot reach internet, right? Let's do the same. Let's determine the end host. In this case, it's going to use Google. So if we try to ping google.com, we're going to see that now we have an IP address that we can use to execute on our captures, and there is a ping reply, right? So let's do that. Let's use that IP that we extract from this test. Again, we are going to use Packet Tracer. Packet Tracer is a really useful tool because we are going to simulate traffic passing through the firewall. We are going to put a packet on the interface that we desire, and we are going to see the resolution of the firewall doing with that packet. It's going to show us all the phases that it's going to use, it's going to do, and after that, it's going to give us a verdict. So in this case, we are going to use that. We are going to simulate traffic. So Packet Tracer is the command input where we are going to put the packet. We are going to use the inside because there is where our PC is. Then the TCP protocol, because we know that we are trying to use HTTPS, the IP of our PC. We are going to use an ephemeral port, a random port, because we don't know what the PC is going to use, right? Now we know the IP that we can use, but we know that for sure that the destination port is going to be 443 because we are going to use HTTPS, right? So let's check. We have phases. It's allow, and now we know that the firewall is dropping it. Actually, as you can see here, it matched a rule, and the rule is blocking it. So now we know that the rule is the firewall actually is blocking it. And then we have the interfaces for the result that we are going to use, and you can see blocked or blacklisted by the firewall. This was simulated, but we know what does the firewall is going to do with the packet, right? So let's use another good tool. Let's use system support trace. We are going to use it on the Clishprom. Here, with the system support trace, we are going to analyze the packet that goes to Snort, right? So, for example, here, we are going to put the command, and then we are going to enable the debug. After that, we are going to put the protocol that we know is TCP in this case, the IP address for our client. We don't know the port, so we can leave it in blank. We don't know the server because we are going to internet. We don't know that. But we know that we are going to use 443 because this is an HTTPS connection. So let's try to check if we do the test, and there he is. New firewall session, so we are receiving the packets. We are processing those packets. We have a lot of information, but we are going to focus right now on this. We have a rule and a time range in this rule. So what about if we go to check on the FMC what is happening? If we go to that path, you can see on the policies that we have our ICMP rule for make the ping test. We have the insight to DMC for extract the files. We have the DNS, and at the bottom we have an HTTPS. But check at the beginning of the rule, there is a little clock there. Let's see what is happening. If we try to edit, we'll check all the settings here. As you can see, we can check the name of the rule, the action that in this case is allowed, the select sources and the destination. We know that for sure the HTTPS is the rule that we need to check because we saw it on the trace, right? But see, there is a time range. Maybe the IT guy is a Patriots hater, so he is not allowing me to see my game. So let's read off of that, and let's deploy. And what about this? Now the internet is working. Was not a total outage, was not a problem with the was just a misconfiguration. But if in a case was a really problem with the connection to internet, now you know how to troubleshoot that, how to check the first packets, what are the first steps that any tag will do before to do something. Maybe you think there is a problem. There was just some Patriots hater that doesn't be allowed to say the game. So, for the conclusion, so what are the best practices to face an internet outage? Well, check the hardware issues. Check your hardware. Check. You know how to do it. Check the faults. If something is missing on the hardware, you can see it. Now you know how to do it. Test the connections. As you saw, we did that at the beginning. We checked that we can ping from one point to another. We can reach the firewall, so the firewall was involved on this issue. Let's do that at the beginning. Take captures. Now you know how to do it. It's really easy, and it's going to be really, really helpful. Take packet tracer captures. If you have an application, maybe you know the port, maybe you know the server, maybe you know the destination, you can simulate the traffic before, do anything before, and see if it's going to work, because you know how to do it, right? You can simulate those packets. Have syslog servers enabled. It's going to help us if we need to troubleshoot further to check what does the FTD is doing with the packets, if there is a problem for the hardware, or just for the rules that we have. Do not reboot the devices. I know that the best way for you is like, okay, let's go. There is an internet outage, just press the button. It's still there, and when it's rebooting, everything is going to be solved. Do not do that. Wait. Take a breath, and if that is needed, as we saw before, okay, do it. But if reboot is needed, take troubleshooting files before of the FMC, of the firepower, of the secure firewall, the FTD, of the chassis, if it's needed. Before to do the reboot, please take troubleshooting files before. So, I hope you enjoyed the session. This is my first time here, so thank you so much for coming here. Please rate the session. If you're a Patriots hater, just evaluate the content of the session, not the guy. Hate the game, not the player, right? Please help me with your survey. And this is a time for questions and ask. Thank you so much. Sorry? Oh yeah, sure. Okay. Okay. Okay, yeah, sure. Yeah. Thank you. Okay. All right. Thank you.